because we will be implementing multi-headed attention with Kiwi Cache and Softmax from scratch in NumPy without like trying to do as few checks in sources as possible, trying to implement everything from memory, which will be almost certainly not possible, but I will try to do as much as I can. And I want to do that to highlight for myself where I still misunderstand pieces. But yeah, so first of all, let's implement Softmax. So as you all probably know or should know, Softmax is a way for us to calculate probabilities from logits, right? So we are essentially given an array, and this array will be size of, okay, so the first is the batch size, so it will be n times classes. So for each element, like let's say one row will be some logits, and it can be something like from minus infinity to plus infinity. Let's say 100, 10, minus 10, 50. So that would mean that we have like 4 classes, and this has the highest chance, according to our model, the highest chance of being like the if we are talking about large language models, right, we are choosing between different tokens in our vocabulary. And this row can be a size, like our number of classes can be a size of vocabulary, which is 250,000 or something, easily. Okay, something broke down. I'm not sure why it stopped sharing my screen. Let me go back. Let me also check that things are actually working. Because I don't want to talk about all this. Never see the recording in the end. So yeah, this is working. Okay, opening this on my phone. Yep, something is working. Let's now share the screen again. Screen, entire screen. Done. Okay, and change the layout. Done. And go back to this softmax and everything. Okay, looks like it's working. Let me check that everything would work on my phone. Okay, back to this, right? So this can easily be, okay, it stopped again. Let me just share my window for now, I guess. Okay. Hopefully it works. So we have logits here, and theoretically it can be up to like 250,000 tokens easily, and each token needs to have its own probability. So we need to convert those logits into probabilities. And how do we do that? We use exponents so that, like right now, this token and this token have pretty similar, like on the same order of magnitude values, but we probably want to change that. We probably want this to be much higher in probability. And we will do that with exponentiation. So how do we do that? We do exponent of element, or exponent of logit, divided by sum of exponent of logits. Then the problem becomes, right, if we have, let's say we have 10,000 logit here, right? It can happen. They are not limited in their sizes. And that would mean that this number becomes huge, like so huge that it overflows pretty much anything, and this calculation will become very unstable. So how do you solve that problem? You divide like numerator and denominator by the same number, which will be exponent of the maximum of logits. So what will it change, right? If you divide two exponents, it's the same thing as subtracting their powers. So then it becomes, instead of this, it becomes logit minus max logits. And the same thing here. Now, the biggest exponent that you can have is an exponent of 0, which is 1, which is definitely a reasonable number, and it never gets to such big values that it becomes a problem. And we don't care that much about the small values, which might become a problem if it's like minus 10,000 power. But we will have another trick down the line in this log softmax here. Okay, so now that we have discussed this, let's try to implement this. So we are implementing logits. We need to find max logit. So max logit will be equal what? Maximum of logits. And actually we need to do np max. We are only using numpy today. And keep dems equal true. Why do we need to keep dems equal to true? Because if we just find, okay, and we also need to use axis. So we are using a specific axis here. Let's figure out which one. So we need to find, for each row, we need to find the maximum in the row. So we will be using -1 as axis here. And why do we need keep dems? So that it doesn't, so that we still have the vector that is like, this keep dems will give us a vector that will be of size 1 nx1 with keep dems. Without, it will be nx1xn, and it will not be broadcasting well. So we have this. Now let's just do what we need to do. So we do shifted value, which is logits minus max logit, and then we do return np exponentiated of shifted divided by np sum of np exponentiated of shifted. But here we also need to use sum over the specific axis. Axis equal so yeah, we again need to calculate it for n value. So x will be 1, and I think we also need to keep dems equal to, so that it works well for us. Okay, so now we will check it after we finish the whole part. So here the problem becomes, we don't actually need just our probabilities. We need logarithms of our probabilities. Why is that? This is because we have cross entropy loss, and our cross entropy loss is basically minus sum of log p true. So if this is a probability minus sum of log p true, P-true is like, what is the probability for the correct class, right? So if we do minus sum for this log of true probability, what happens then? Do we just do logarithm of these softmax thing? That would be problematic. Again, for instability. So if we do logarithm of something very, very close to 0, it will be unstable again. So yeah. It kind of gave us a hint here, actually. So theoretically, we should be doing this on our own, figuring this out. But yeah, it has given us the hint. So we don't want to do that. Instead, we are looking at logarithm over this function here, right, essentially. Shifted one, but it's still the same thing. And then it means that we can do instead the logarithm of division is a subtraction of logarithms. So it can be log exp of of log it, and then minus log of sum. So essentially what is written here, because here, as you can see, we have already our it already substituted everything. So, okay, now we need to do the same thing as here, mostly. I will copy paste it, but shift it here, so it will be, instead we need to find the logarithm. So it will be shifted. Oops. Not that, it will be shifted. Shifted is basically this thing, right? And now we need to do also the sum of shifted minus log of np log, obviously. And again, we are doing np sum of shifted. And here we need to do, again, axis equals -1, keep teams equals true. So now let me see what's the question or like some comment from someone in the chat. Hi, is there a platform where we can practice questions like this? I don't think there is a platform where we can practice questions like this. I just asked Claude to create such questions for me. It does a pretty good job. I don't think that there is much benefit in having a platform, but actually I'm lying to you. I think there is a platform like this. DeepML. No, DeepML platform. Yep. So this is the platform where you can find a lot of such questions. So let me just copy paste the link to the chat. But I'm not sure if I were you. Oh yeah. I'm not sure if I were you if I would use that or just use a large language model. Okay, I think this should work. Let's see. Part A. So something is not working correctly. We have good news and bad news. The good news is that we at least have correct dimensions. The bad news is that something is wrong in our computation. Okay, let me see, there are a few more questions. I'm entry level, just a bachelor's with no work experience yet. Is this viable for me? I don't know. Do you already know what's going on with NumPy? Did you have your Python courses? Do you want to understand how large language models work? Then it might be relevant for you, but it might be quite heavy for understanding if you don't already have some experience. So up to you whether it's relevant or not. So how would I debug this. Let me just move the part B outside of here. And let me do debugging. So let me also get the tests. Okay. I will repeat those here, and then I will do test softmax, test log softmax. Okay, so here, where is this? Random 3, 4, 5. Okay, only here. So custom access. Oh, I see. We have made a mistake where we are not using the correct access here and the correct access here because we want to be able to use the custom access. I didn't see that. Okay. And now Softmax passed. Runtime warning and blah blah blah. Okay, so for this we already are getting issues with the initial value. Oh yeah, here we want to do just np sum. We want to do exponentiate this thing. That's something that I have missed. Okay, yep, now we have passed all the tests for part A. Let's go for part B. Now we need to implement cross-entropy loss and cross-entropy backward pass. So for cross-entropy loss, mean cross-entropy loss over batch using log softmax. So again, let's first discuss what's the formula there. So I think I already have written it above, right? Yep. So this is what we essentially need to calculate. Sum of logs of p true. So we already know the targets. We just need to choose the target. So log prob will be equal to log softmax. How do we define that? Okay, log softmax of logits, and we are not passing the access parameter. So these are our log probabilities, and it will still be of shape n times c. But now we need to choose specific. Oh, actually here we are also dividing by n. That's something that I have forgotten, just to be clear, because we need to find average loss. It shouldn't scale with the number of instances in our batch. So now log probability will be log softmax of logits, and now we just need to choose the correct values. I hope that I remember correctly that targets is the correct thing. So log true probability will be, let's also change this to log probability targets. And now that we have chosen the target will be shape of n, and each one will be in the correct place. So choosing the correct value in this matrix. Now we just need to return np mean of log true probability, and we have minus here. And now what we need is, here we need to do a similar thing. So here we will be returning, we have a matrix, and it is like some elements. So as we have, for example, the row, okay, let's say we have a matrix, one row will be 0 0.7, 0 0.1, 0. Let's do 0 0.25, and then 0 0.05, right? So these are our probabilities, and let's say that this one is the correct class. So what will be our loss calculation? As we know, the correct loss is y minus y pred for softmax, for cross entropy loss with softmax. So here we can see that we need to do, okay, so if y is true, it will be 1 minus y pred. So the loss will be very small when we are predicting close to 1. But if it is false, then it will be 0 minus y pred, and it will be a negative thing. So now we just need to do what? We need to subtract 1 in every place where we have where the value is not our target. Okay, so how do we do that? We can do first of all, we need to calculate log probabilities. Oh, actually, we don't need log probabilities, we need normal probabilities. So probabilities will be softmax of logits. And now we need to do probability minus 1 plus, okay, loss will be, no, gradient will be prob minus 1, but then gradient where we have targets plus or equals 1, and then return grad. I think this is it. Let me see what else. Oh yeah, I got response. Thank you. You're welcome. Now let's see if the tests are passing. Part B, cross entropy loss targets. Okay. Now again we have the same thing that we need to do. Part B tests. Let's figure out what's wrong. So where is part B? Part B, part B, here it is. And moving other parts outside. Focusing just on part B, test cross entropy, and test cross entropy backward. Okay, now let's see which test we're actually failing. So 10 minus 10 minus 10, the first one. Print Okay. I need to print microcentric loss and see what's going on there. So microcentric loss. Okay, in microcentric loss, I need to see. Yeah, for some reason it's relatively big. Okay, this is not expected. Okay. Oh no, that's correct, right? Just have one value. Yeah, for whatever reason, I'm not choosing, okay, this maybe? Okay, part B loss past. Cool. So I was just choosing incorrect values here. That's reasonable, or that's a mistake, but part B loss past, now we need to do targets. So I think here we'll have the same issue. So gradient for each of those rows here. Gradient check failed. So we have is it vice versa that we grad equals this, and then here we will need to do minus equal 1. Nope. So this is these are both incorrect. I will need to check now so that I don't waste more time. Oh, I also obviously need to do so they're saying, yeah, that there I need to do this. So NP arrange length. Let's do logits shape 0. Let's extract this, and will be this NP arrange. And so yeah, to be explicit where we are subtracting this. So targets, and here we do need to subtract -1. So I was also incorrect initially. Let me check. Subtract 1 at true class positions. Oh yeah, because we want, I don't know why. Yeah, because we want bigger loss. There. Okay. Still incorrect. I thought this will be correct now. Softmax logits. I don't know what's wrong. Let me ask. So maybe I was correct in the beginning. Oh, we actually have this value here. So softmax -1 where ith is equal to target. Okay. Okay, now I don't know, the Claude, I don't have any more tokens there. Oh damn, am I streaming? Yeah, looks like I am. Picture was removed to maintain quality. Okay, yeah, I don't know what's the issue here, because the implementation made by the LLM is just the same one. It says that I'm modifying something in Softmax in place. No, I'm not doing that, so I don't know what's going on here. And let me see whether I'm actually modifying in Softmax anything in place. No, I do have max logits and I do have shifted. Everything is not being modified in place. Then I don't know what's wrong. I will just continue with the next parts. So now we have scale.product attention. This will be fun. So what do we need to scale to calculate scale.product attention? Oh yeah, everything is already written for us here, right? Which is nice. Oops, sorry. I'm used to. Okay. So scale.product attention. Here is our value. So we also need to calculate the square root so that it's not, so that the scale of this dot product doesn't increase with time. And then we need to multiply this by our values. Yeah, I actually don't know what to write here. Let's just implement this. So here we have queries, and we need to do return, just return. Oh no, we also have mask. So attention will be Q at K transpose. So we will need to transpose these two x's. So So it should be eventually, what size should it be? It should be number of tokens by number of tokens, so initial batches by initial batches. So we need to multiply those two, like -2 and -1, or I think it should be -1 -2, like this. And then we divide. First of all, we need to calculate dk, which is equal to, what is this? So for dk queries are we have embedding size times dk. So this is our query, and then it means that for our query we will have embedding size by dk, and dk will be q shape -1. So here then we are doing an psqrt of dk, and we also need to, oh, that's actually it. We now need to do attention or pre-attention, then attention softmax will be softmax of pre-attention. Oh, actually no, we need to do softmax after applying the mask. So if mask is not none, we need to do pre-attention will be equal to np where mask is true, position is masked. So we need to do something like -1 9, because we don't want to use -infinity here for, but yeah, it's essentially like after softmax it should be pretty much 0 probability, and then otherwise it will be pre-attention. Okay, now once we have applied the mask, we can do a softmax. And once we have done softmax, we do return softmaxed at v, and that's it. Let's see. Oh, I accidentally put t here. Okay, part B loss. Let's skip this test. Scale dot product attention. X's don't match. Let me check. What is the correct transformation there? This is obviously something that you're not grasping fully. Okay, actually I'm doing the correct things, but I need to do swap access instead of transpose, as I'm doing right now. So let's see. Okay, swap access. We have an assertion error. part C tests. Out shape. Oh yeah. What should we be returning here? Oh, I am not creating causal mask, right? I think that's the issue. So return np trill. I think, yeah, lower triangle of an array. So np once, and shape will be okay. Sequence length, ideal. Okay. But here, np triangle by default, lower triangle. So I think it should be np once of shape sequence length times sequence length minus np triangle, so that it's 0 everywhere in the lower triangle and 1 in the upper triangle. Let's see. Okay, there is another issue here. Let's see. Let me just ask ChatGPT. Okay, so I also need to return weights, it says. Fine. Okay, I was just returning incorrect values. And now that I have fixed that, everything is passing, at least for this part. So part C passed, now let's implement part D. So multi-head attention. Multi-head attention is even trickier, but here, what do we need to do? Is it just reshape? So I think return x reshape of self. Okay. X shape 0, x shape 1, and then we need to do t, which is x shape 2 divided by dk and here it will be x shape, and here it will be self d model, self dk. Okay, so now we need to do forward projections. Let me check what's the message. I'm preparing for mostly my engineer, but doesn't mean that I don't have to know how to calculate softmax and how to do self-attention. Okay, so for forward we need, it's strange. We're usually given not this for forward, we are usually given okay. We already are given query key value, and I will just need to, do I have any weights? Oh yeah, I actually do have weights. So Q will be equal to query at self we Q, and the same thing for key at self weights for k, value will be self w v. So now we need to do split heads, and actually let's do it here. Split heads, and we have self. And now we need to do attention weights will be scale.product attention for q k v. I think this is actually like incorrect. We should be being passed just an input that is array of embeddings, and it will be all of these things, query key and value, it will be just the same array, but we are multiplying it by different things, and that is giving us q, k, and v. Yeah, so that's the difference between the normal attention implementation. But okay, let's assume that we are giving these three. So now we did that. Output projection. So merged v merged attention will be self merge heads of attention, and then return merge attention at self weights for the output. Oh, I see. I have implemented incorrectly the causal data type. Let me just check how. Okay. So there is the right way to implement this, which is, oops, So it will be in P1s. Oh, yeah, I see. One of the issues is that should be the shape like value, and also dtype equals boolean. And now for triangle k equals 1. Okay, so this is incorrect. Oh, I see. There are two different functions. There is try u and then there is try l. And I need to do try u. Great, now we get to multi-head attention, and we can see that multi-head attention is also not working. Okay. So this is incorrect. I need to reshape differently. Oh yeah. I need to reshape to self-num heads. Okay, this was correct. This is incorrect. Self-num heads and self-decay divided by self-num heads. Okay. So this is after. Okay, we have checked this. T model divided by ash. Oh, I also need to transpose after that. Okay, that's what I was missing. So this is not enough. We are doing this as the first step. So here we are reshaping this as the first step. So here reshaped is this, but then we need to return reshaped with transposal. So let's now think about this. So what we are even trying to do. We are now trying to put this num heads as the second value, because we will be doing independent multiplications on both the batch size, the number of n in our batch size, and then for the num of the heads, and everything else should stay the same. Okay, so now here we also need to do, oh, I forgot even to return things, right? But this is not it. So return this, but transposed, we need to first transpose back is x transpose again, changing those two in places, and then x shape 0, x shape 1, and self-d model. Yeah, this is helpful actually. So we are getting this, then we need to transpose, and then this 2 and 3 will be combined back in the model, and hopefully this now is correct. Okay, well, we are almost done. Obviously there are still some issues, but I'm already streaming for what, almost an hour. I need to go and have lunch. We are almost done. There is just like cache, so that is the difference. There will be that we have cache, which is an array where we will be appending items before we are splitting it into heads. Well, yeah, this is heavy, especially the parts where you need to figure out the dimensions. I clearly need to work more on this, but whoever is watching this, thanks, and see you next time when I have hopefully more time.